solve this nonlinear system of equations. Got x squared minus 2y is equal to 2, and y is equal to x squared minus 3. So now notice that y is written in terms of x in the second equation. So we can actually use the same substitution method that we use for linear systems of equations and substitute this y in the second equation for the y in the first equation. So doing that, we get x squared minus 2 times y, which is x squared minus 3, is equal to 2. And before we move on, notice that now everything's in terms of x. Well, it's in terms of x squared, but still, there's only one variable. So we reduce this to a case that we're very familiar with solving. So now the first thing I want to do is distribute this negative 2 into this difference. So we have x squared minus 2x squared plus 6 is equal to 2. And combining like terms, x squared minus 2x squared is minus x squared plus 6 is equal to 2. And now since I want to solve for x in this case, I want to subtract a 6 from each side of the equation. So negative x squared is equal to negative 4, which dividing both sides by negative 1 turns into, x squared is equal to 4. So then taking the square root of both sides, we get that x is equal to plus or minus the square root of 4, which is plus or minus 2. So now we have two solutions for x, namely x is 2 and x is minus 2. But we have to solve for y as well, right? Since this is a linear system of equations. So, this is a nonlinear system of equations. It's still a system. It's an x and y. So we want to plug x is equal to 2 into one of the original equations. And so we look for which one's easiest. They both look kind of tough, but I'm going to plug it into the second one, because the second one at least looks a little bit nicer. So plugging x is equal to 2 into y is equal to x squared minus 3, we get that y is equal to 2 squared minus 3. Oops, sorry. Got ahead of myself there. So y is equal to 4 minus 3, which is just 1. And now we want to plug in the second value of 2. So we want to plug x is equal to negative 2 into that equation. So we end up getting y is equal to negative 2 squared minus 3, which is still positive 4 minus 3, which is just 1. So for the first set, we end up getting the solution 2, 1, right? X is equal to 2, y is equal to 1. And for the second, we get negative 2, 1. So this system has two solutions. Namely, at 2, 1 and at negative 2, 1.